Siyempre, bilang mga botante, meron tayong mga hinahanap sa ating national election. Ito ay transparency, security, at assurance. O kung talaga bang naitala ang boto natin. At itong tatlong nabanggit ko, wala tayong kasiguraduhan kung naganap man ito noong nakaraang halalan. Nasa panahon na tayo na ang teknolohiya ay lalong lumalago. At upang matupad ang tatlong nabanggit ko, may isang teknolohiyang naimbento. Ito ang blockchain.
Who bought it? Who wrote the software? How was that software coded, right? When it was delivered from the company to a polling station, what happened when it was on the truck? Did the truck make a stop? Did somebody try to change the software then? Once it got to the polling station, did any of the polling officials interfere with it, right? Did they try to apply a magnitude? Did they try to change the code? Did they try to unplug it? Did they try to block the transmission of data? Any one of these issues along the way completely could invalidate an election.
The sad part about our election system now is that it is a very esoteric discussion. Meaning if you are not conversant in IT terminologies that pertain to encryption, it is very difficult for the common man to understand what is going on.
Ang mga balota ay ipinapasok sa mga VCMs o vote counting machines na matatagpuan sa bawat presinto. Mula sa mga VCMs ay tatlo ang pinagpapadalhan ng resulta ng halalan. Una, ito ay direktang ipapadala sa mga Municipal o City Board of Canvassers o MBOC at CBOC na matatagpuan sa munisipyo o City Hall. Mula rito ay ipapasa naman ang mga resulta sa Provincial Board of Canvassers o PBOC at mula sa PBOC ay ipapadala ang provincial results sa National Board of Canvassers o NBOC na matatagpuan sa Batasang Pambansa o Kongreso. Pangalawa, mula sa VCMs ay direktang ipinapadala ang resulta ng halalan sa Transparency Server na matatagpuan sa Pope Pio Center sa Manila. Ito yung nakikita natin sa TV na unofficial results. At pangatlo, direktang ipinapadala ito sa COMELEC Central Server sa PICC kung saan mayroon rin silang sariling bilangan.
Bakit hindi tinupad? Unang-una, tinanggal nila yung 4 na major security features ng automated election system. Hindi nila sinunod yung digital signature, hindi nila sinunod yung voter receipt or voter verified paper audit trail, hindi nila sinunod yung ballot security, at hindi nila sinunod yung source code review.
They forgot to tell us about the Meet Me room. They forgot to tell us about AWS going to another country. And they forgot to tell us about a queue server.
Mula sa mga VCMs ng bawat presinto ay dumaan ang mga boto sa isang queue server sa halip na direktang ipapadala ang mga resulta ng mga MBOC o CBOC, Transparency Server at COMELEC Central Server. Ang queue server na ito ang sumasala sa lahat ng resulta mula sa mga VCMs. Ang queue server na ang siyang nagpapadala ng mga resulta sa Municipal o City Board of Canvassers, sa Transparency Server at sa COMELEC Central Server. Ang mga encrypted results files na ipinadala ng mga VCMs ay dapat selyado at walang sino mang nakakakita ng laman nito. Pero ayon sa pagsusuri ng mga eksperto, hiwa-hiwalay at nabuksan na ang mga results files na ito nang matanggap ng destination servers o paroroonan nito. Nagkaroon rin ng mga regional hubs na hindi kasama sa napag-usapang election system. Hindi ito sumailalim sa anumang testing o security review na nakasaad sa ating batas.
Question is, there is such a queue server. There's a queue server.
Called queue server is part of the transmission services.
So there is. Yes.
Audit logs ang nagsisilbing logbook ng vote counting machines. Dito makikita ang tala ng lahat ng mga naganap sa VCM na iyon. Pati date at time ay detalyado ang record nito. Mga impormasyon tungkol sa makina, ang machine MAC address, machine physical ID number, precinct ID number at location, application version, framework build version, sinong kasapi ng Board of Election Inspectors ang nag-login, mga diagnostic tests, mga balotang ipinasok sa makina, mga errors ng makina, oras ng pagbukas at pagtapos ng botohan, pagbilang ng mga boto, pagpirma ng hindi epektibong digital signatures, pag-transmit ng mga resulta, pag-print ng election returns, at hanggang sa pagsara ng makina. Parang logbook na minomonitor ang lahat ng pangyayari sa makina. Ang election returns naman ay ang tala ng bilang ng lahat ng boto di umano na pumasok sa makinang iyon.
There's a process, whether you like it or not. The system automatically stamp marks an audit log, the date, the time, and the identification of the machine. Now, that thing that would show you the jump would also raise the red flag and says, why is it not sequential? Time and again, we've been saying all of this information, all of these discoveries already subject for digital forensics even as way back in 2010. And it's still happening to this day.
Ang decrypted ballot images ay ang selfie ng balota. Ito ay ang mirror images ng paper ballots natin. Ito ay dapat faithful reproductions o makatotohanang kopya ng ating balota. Walang labis o kulang. Pagkapasok sa VCMs ng ating balota, agad itong kinukuhanan ng litrato sa ibabaw at sa ilalim. Ang picture images na ito ay mapupunta sa SD cards na nakalagay sa makina. Ang sequence numbers nito ay naka-assign na rin at dapat ay magkasunod-sunod ito. Kumbaga, ang unang magpapasok ng balota ay siyang magiging image number 1. Ang pangalawang botante naman ay si image number 2, and so on. Ibig sabihin, kung mayroon 100 botante ang presinto A, ang last file numbers na dapat ay makikita sa SD card ay image number 100.
In the case of precinct number 40 in Pili, Camarines Sur, nawawala yung ballot image sequence numbers 1 to 40. If I remember, it's 57 to 63, 78 to 83. All in all, ang nawawala in Pili, Camarines Sur would be 155 ballot images. But then we found out that the ballot image sequence numbers reached 767. Then these missing ballot images were tampered with, and they were added at the bottom. That is why the ballot sequence number did not end at the maximum ballots that were cast at 612, but naging 767 siya. From 612 plus 150, 767. That's why it added 613, 614, 615, 616, 617, because it could not go back anymore to number 1, number 2, number 3, number 4 until number 40, because those numbers were previously assigned already.
The square is the square is to facilitate the visual determination of how the machine appreciated the ballot, the votes or the shape.
But the COMELEC never announced to the entire world that there will be squares in the scanned images.
It's part of it was shown during the source code review. We showed that. It was available then. It was also reviewed by the SLI. We didn't hide that functionality, Your Honor.
Was it mentioned that there will be possibility?
No, we were not apprised of any information that there will be an insertion or a deletion on the image. Based on a review, that image should be a complete, faithful reproduction. There should be no alterations. If there's any insertion or deletion of any image on that image ballot, that would render that image questionable, because you have now the ability to edit. And if we had seen that in the source code, we would have objected to it immediately. Please.
The law provides for an optical scanning of the ballot inserted.
Correct.
So no alteration can be made. If the design of the BCM to the SD cards allows the COMELEC to insert anything there like a square, they can also insert any kind of shade.
Case, blockchain is used in a decentralized way so that no single person or group has control. Rather, all users collectively retain control. Kalat! Diba? Yung database. Diba? Decentralized blockchains are immutable, which means that the data entered is irreversible. Ibig sabihin, hindi mo ma-delete. Diba? For Bitcoin, hindi mo ma-alter, hindi mo ma-edit. For Bitcoin, this means that transactions are permanently recorded and viewable to anyone.
Alright. Ayan. Ngayon, papakita ko sa inyo kung itong ginawa kong voting system, no? So, wala naman akong VCM. So, ang ginawa ko, computer na lang. So, similar lang din naman siya kung paano mag-cast ng vote. Itiman at ilagay sa balota. dito, imbes na ilagay sa VCM, submit button na lang kasi pareho lang naman sila ng proseso kung paano binibilang ang boto. So, ang VCMs natin, no, ang traditional na ginagamit natin is client to server architecture. So meaning traditional database yung ginagamit natin, or RDBMS, or relational database management system. At pagkakaalam ko, ang ginamit ng Smartmatic ay may queue server. Okay, yung sinasabi nilang intermediary server, kung napanood niyo yung part 1 na ginawa ko dito, no. So ito, similar siya doon. Okay, so ang ginamit kasi ng Smartmatic dyan na database ay Oracle. Sa atin, MySQL. So naka-record ba ako? Ayan. Yun. So tignan natin So itiman at ipasok or submit. So okay. Si Attorney Randolph Libayan, yung binoto ko 100%. So tama yung binoto ko. So ngayon, ipapakita ko kung gaano kadali i-manipulate yan. So ito, pag nakita natin, tama. Okay? So, paano madaling i-manipulate to? Sa pamamagitan lang ng isang code. Okay? Lagay lang natin dito, isang code, ganyan lang. Okay? Go. Tapos, refresh. Nagkaroon si Nico David ng 67%. Gets? Nang wala akong binoboto, isa lang binoto ko. Diba? Si Attorney Libayan lang. Pero bakit nagkaroon ng Nico David? Dahil sa code na to. Okay? So, maaari, diba? So, ganun yung konsepto. Oh, okay? Pinakita ko lang sa inyo. Kung paano madaling i-manipulate doon sa intermediary server. Kasi, kung napanood nyo yung isa kong video, gumagawa rin kami ng voting system. Pero hindi ganito yun. So, syempre, mas maraming security yun. So, ano lang naman to For example lang naman to. Okay? So, ang architecture namin doon, may mga load balancers pa, diba? So, parang queue server namin, similar. Kasi nga hindi pwede walang queue server kasi loaded doon sa application server namin. So, ganun. Sana na-gets nyo kung paano madaling dayain ang traditional database because pwedeng matamper yan, pwedeng kang mag-create, read, update, delete, ba? O, delete natin to. Ayoko. Gusto ko si Nico David lang. Delete ko si Attorney Libayan kasi anti-axe yan ba? O, delete. Refresh. Hindi, wala na siyang boto. 100% kay Nico David lang. Diba? Ganun kadali yun. Okay? So, yun guys. So yun guys, nandito tayo ngayon sa ginawa kong code using Java, a blockchain. Okay, yung code ng blockchain. So meron tayong blocks at meron tayong main which is the blockchain.java. So hindi niyo naman na kailangan pang masyadong aralin yung code. Kumbaga in-example ko lang para mas lalong maintindihan nyo. So nag-create ako ng sarili kong blockchain. Simple. Okay? So, meron previous hash, yung data, saka yung hash niya. Okay? So, ito yung Genesis block. No? So yung nauna, syempre, ang pangalan niya, Genesis. Susunod, Exodus. Joke lang. So, yun. Blocks, Genesis. So, ito yung malinis, Lodi. Okay? At ito namang nasa baba, ito yung tinampered. Okay? Ito yung corrupted. Okay? Yung inedit. So, hindi siya Lodi. O, ngayon, itong mga previous hash and hashes, okay, itong isang bloke na to, for example, yung codes na yan, i-validate niya yung mga hash and previous hash, okay? I mean, yung previous hash ang iano niya, i-validate niya. Same as dito sa code na dinaya, okay? So, sige, tingnan natin. So, makikita nyo, itong hash hello block, ang number niya ay 54005444. Ngayon, ang previous hash niya, dapat tugma. So, negative pala to. So, negative 54005444. So, tama. So, nung vinalidate niya, ang lumabas, true. So, pumunta naman tayo kay hindi Lodi. So, yung corrupted blockchain by replacing hello. So, nireplace ko, no? Nireplace ko yung hello. Ito. Nireplace ko yan, hello block. Okay. Ng tampered. So, blockchain na tampered. So, okay. So, hash tampered block is 13825434442. Ayan yung binago ko. Yun yung inedit ko. Ngayon, yung previous hash, kukunin niya ngayon dito kay Genesis. Okay? So, eto, tugma. Okay? Tugma to. Yung previous hash niya. Yung tinampered ko, hindi. So, ang lumabas is false.
Of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2, and number 2 points to number 1. Now the first block is a bit special. It cannot point to previous blocks because, well, it's the first one. We call this block the Genesis block. Now let's say that you tamper with the second block. This causes the hash of the block to change as well. In turn, that will make block 3 and all following blocks invalid because they no longer store a valid hash of the previous block. So changing a single block will make all following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You could effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this, blockchains have something that is called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes about 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism makes it very hard to tamper with the blocks because if you tamper with one block, you'll need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there is one more way that blockchains secure themselves, and that is by being distributed. Instead of using a central entity to manage the chain, blockchains use a peer-to-peer network and everyone is allowed to join. When someone joins this network, he gets a full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, each node adds this block to their own blockchain. All the nodes in this network create consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with a blockchain, you'll need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. So this is almost impossible to do.
So gaano-ano ang power ng blockchain? It's democracy. People power. Ang kapangyarihan nasa botante, wala sa mandaraya. Free will. Kung meron mang butas dito, maaring vote buying na lang. Blockchain technology is just a tool.